Welcome to today's video. My name is Wycliffe, and in this session, I want to share with you how you can obtain a texture of your elevation data, like how you can check the roughness of your region of interest. So we will start by loading our libraries like RGEE, and then I think for today, we will only use RGEE. Okay, we'll not need map edit because we'll get our boundary from the global database. So we'll use the world, we'll we'll get the global database at of regions level 2, and then we'll extract a Kericho layer from that, right? But of course, we need to initialize our RGEE session. Okay. Once that is done, we can go ahead and import the data of all countries. So we'll use a feature collection because it's now not image collection. And then we will pick dataset. And from dataset, we are only interested in global administrative layers, level number 2. Yeah, that is the least or the most fine level of global administrative layers from FAO. Okay, I'll change this to world. All right, then we want to pick only one region. And in my previous videos, I've shown how you can filter feature collection if you know the name of your location. If the name of your location exists in the database, then you can pick it. So we will, after getting our world, we will filter using Earth Engine. First of all, we filter, and then we say where Earth Engine filter $ equal sign or equal function, and then we need admin2 name because we have admin2 as a property name in world, okay, in world feature collection. And then we are looking for Kericho. To confirm that we have this as a property name, because sometimes it's not obvious to tell that, we can pick the world, right? And then we pick the first feature, and then that first feature, we look at property names, right? Property names. That's a list, and from that list, we can get information, right? So this indicates all the attributes, or you can call them the columns in the database. So admin2 name is there, and that is where the level of our analysis or the name of our location is available, right? To check all the names that are in that property, in that list, you can say from world, you can aggregate array, and the array you want to aggregate is admin2 name. And then you can print that. That's a list, so you get information from it. Okay, so that will tell you all the administrative level names that are available. We can sort them. So aggregate array and then sort. Okay, so that they are in alphabetical order, and then you get information. Some are not available, majority are not available, so it will take us quite some time to get to Kericho, and you can see there are over 38,000 in that list. So we can pass it to a list object and then look for Kericho, but of course, I'm pretty sure that Kericho is one of them, just in case somebody is doubting. Okay. So this will give us our region of interest, which is Kericho, and then we will get elevation layer, which is Earth Engine image. This can be any other image of your interest, and then we look for dataset, and then we look for SRTM. SRT, $SRTM, okay? That gives us the elevation, and then once we have that elevation, we can clip it for our Kericho region. In the next step, we take the elevation and then we clip it to Kericho as our bounding box, okay? So if you want, you can visualize this. So we can center our object, map $, center object, and the Earth Engine object we are using is Kericho, and we are using it at a zoom level of say 9. Okay. Then we can then add our layer, map.add layer, and the layer we are adding is Kericho 11. And of course, that is an Earth Engine object. And then after that, we can add visualization parameters. And these visualization parameters are there to improve the quality of the image. For example, if we print it just like this, we will still see our elevation within Kericho. Here, this is the elevation, but everything is gray because it's taking the minimum and maximum values all the way from the deepest part of the land globally to the highest part of the land globally. So the regions here are appearing gray. So that is why we need to adjust for our local area. And in adjusting, we provide a list of visualization parameters in which we can set a minimum value, we can set a maximum value, and we can set some good color palette, right? So to get the minimum value, we have no idea. Sometimes you have no idea what the minimum value of elevation is in your area. So you can reduce this, Kericho 11, you can reduce Kericho 11, then you reduce region, and then the reducer, you can use EE $reducer, and then the reducer you want is minimum, for example, if you want the minimum elevation. And then the geometry is within Kericho region, and then scale. Scale, we can set it to say 1000. I know the resolution here is 30 meters, but we are using 1000 to speed up the process. Okay, and then we can get information from the dictionary. Okay, that gives us around 1238. So at least we have some idea on what the minimum elevation can be. Okay, what about the maximum? We just go back and change the minimum to maximum. And that gives us 2838. So we can stretch it up to 2800. Okay, then the color palette, let's say the low altitude regions, we mark them with blue color. And after blue, we have some green shade. And after that, we get to yellow in the mid upper. And then we go even to orange and red. Okay, then we can visualize a more colorful view of our area. So this low altitude, as you descend towards Lake Victoria, you have low altitude. As you go towards Molo and towards Timboroa, then you are ascending to higher altitude. Okay, so that's the elevation for our region. What about the texture? Here we only know the altitude. We don't know how rough these regions are. Being a high altitude does not mean it is rough terrain, right? It can be high altitude, but just a plateau. It can be low altitude, but the terrain changes very fast. So we need to aggregate pixel values within a region. For example, within a circular area, we can put a window to look at the pixel values in that region. And then the standard deviation, if the standard deviation around those pixel values in that small region is high, like they are very, very high values, low values, high values, low values, then that's a rugged or a rough texture region. So that can be important for somebody who is planning, for example, transport network or something like that, or to understand why some goods are not reaching some places on time, or some places are a bit difficult to navigate. Okay, so let us find out how we can calculate texture of our elevation data, because we have altitude. I mean, it doesn't have to be elevation. It can be um, any other image of your choice. So we will take our Kericho elevation, and after taking it, we'll reduce it. Yeah. So we reduce it with, sorry, that's not $. We'll reduce it with reduce neighborhood. Yeah. Because we are looking at neighboring pixels. Yeah. I don't know if I can zoom deep enough to see 1 pixel. Okay. Let's say we are almost seeing 1 pixel somewhere here. So if we know the value of this pixel, what about the neighbors? What do the neighbors say? If the neighbors also have almost the same value, then that's generally a flat, smooth textured region. But if there is a drastic difference or erratic differences between the pixel value here and the neighbors, then that's a rough terrain. Like there's valleys and mountains, okay? So that we can get by using neighborhood analysis, right? So in the neighborhood, what do we provide? First of all, we provide a reducer. For example, we can decide to use a variance or standard deviation. In this demo, we are going to use a standard deviation as the reducer, okay? So we are checking the variation among neighboring pixels, okay? The other thing which we need to provide is called kernel, like which moving window, which window do you want to view the neighboring pixels, okay? So for that, we use Earth Engine kernel. And then for the kernel, we pick a circle for this case. And then we set 7 as the number of neighboring pixels, right? So we run that. There is a problem. Let's see where the problem is. It's in the spelling of circle. Okay. Then we run that. There is still problem. What problem is that? We have standard deviation, reduce neighborhood, and then reducer and EE kernel. The problem is in the kernel. Okay, it should be capital K. Okay, perfect. So we have a texture layer for our elevation. So it will show us how rough a region is. Okay, so let's do the visualization. One, we'll map our territory layer, and then we will compare it with the elevation layer. So we use that bar. With the texture layer, we'll use that bar, and then we provide something we call texture as the image, okay? Then list the minimum and maximum values for texture will be different. So if we set it like this, and maybe let's use different colors so that we see the difference, okay? So for the colors, we can set it to say white for the low or for the smooth regions. And then we go to maybe green for the relatively rough, then yellow, quite rough enough, and then brown for very, very rough terrain, okay? We need to close this again so we can pull one bracket back and then enter the rest, okay? Then we can run this. Is there an error message somewhere? No. Okay, so we can see, you can see what I meant, that everything on the right image, which is supposed to be the texture, is white. Everything is white. So it means everything falls in the low end. So everything is below these values here. So we need to check the minimum and maximum values for our texture, because those are the values that we will pass here, okay? So just the way we did with the reduced region for elevation to get this minimum and maximum values, we can do the same for texture. So let me see if I can go back and find that reduce. Aggregate get info, not really. And then, okay, reduce region minimum. Okay, so what we replace here is just this. We replace with texture, and then we leave everything the same. That's a dictionary like before, and then we get information. Okay, I'm using up arrow key to see the previous code. Okay, so the minimum texture is around 37. So we can set this to 37. And then what about the maximum texture? So the maximum texture is 241, you can see. So our ranges were way, way higher than that, and everything was looking white, because white is the lowest, is the color we assign to lower values. So we can say 245, okay? Now we will see the texture also quite clear, okay? So that is the texture. So these orange or brown Yellowish regions are having high variations in the neighboring pixels. They are rough terrain. They are rough textured regions, or they are places you won't want to walk into. But the white regions are generally flat, right? Are not so rough. Okay. Cool. So if this is something you need to know the terrain or the roughness of a region, or how different or how rough the texture of your location is, then you can use this. Or if you are using different images like vegetation index or something else, you want to see which areas had the greatest variations in different in the neighborhood, in the neighboring pixels, like where do we have heterogeneity in the neighbors, in the neighboring pixels. So you can use texture with the neighborhood analysis, and you can adjust this circle accordingly, or the radius, the number of pixels to focus your circle on for the kernel to reduce, to get the standard deviation. How many pixels do you want to focus in? Okay, thank you so much. I wish you happy coding. And if you like this, you can share with your friends who want to do these kinds of spatial analysis. I will leave this code, a link to this code in the comment section of this video. And also feel free to share it with your colleagues. Always remember to cite the data sources you are using and also the packages that you use in your analysis. So thank you and happy coding. Bye-bye.